All right, in this video, we're going to be talking about 15.8, an introduction to complex numbers. All right, so we're going to simplify each radical. So now what's going to happen is you're going to see things like this: square root of negative 100. So at the beginning of this lesson, when we were trying to figure out what the answers were, if it was a square root of a negative, we could just say no real numbers, which is still true, but no longer no solution, because there is a solution to this, and it's a complex number. So what happens is anytime you have a negative, we're going to let the letter I equal the square root of negative 1. So that is what I would represent, and it's going to help us continue doing work. So what happens is anytime I have a negative, I'm going to let it become an I, and then really I now have the square root of 100, which we know is 10. Now the way we write this is you write the number first, and then I next. And that's it. So again, so what we're going to be doing here is anytime you have a negative, you're going to pull out an I and then pretend it's positive and then work out the math. So let's look at another one. So we have the square root of negative 49. I see a negative, so I pull out an I, then pretend this is positive, so the square root of 49 is 7. So 7I would be the answer. No, your calculator will not do this because of the negative. So if you pull out the negative, write the I, then you could type the square root of 49 and it would say 7, and then you know your answer is 7I. Let's look at another one. Square root of negative 18. So I know my answer is going to have an I, and then I'm going to split 18 into 2 and 9, 3 and 3. Takes two numbers to come out of the set, and then I have a leftover 2. So I actually prefer this method, but I believe what your homework likes. So you can write like this, or what a lot of mathematicians and books would do is 3i. So the I still comes after the number, but then square rooted 2 so the I doesn't look like it's inside the square root. I will say as we progress, this is how I'm going to write it, but you can write it like this as well. So we have square root of negative 72. So again, I pull out the I, and then I'm going to work out the work. So this becomes 2 and 36. 6 and 6. You could keep going if you want, but it does only take two of the same numbers to pull out. So I pull out the 6, and then I'm left with the 2. So I have 6i square root of 2. So the only thing that's being added in this section is the fact that if you have a negative inside of a square root, we're going to have an I. Other than that, it's the same process that we've been seeing throughout chapter 15. We got number 2. Number 2 says identify the real and imaginary parts of each complex number. So what makes something a complex number is that it has a real part plus an imaginary part. And together, it makes a complex number. And we typically write this as A, so the letter A will represent the real part, plus BI would represent the imaginary part. So when we write our answers as complex numbers, we do need to write it as A plus BI. So what you're asked to do in this section is just to note what's the real part, what's the imaginary part. So if you're given something like this, 5i, the real would be 0 since it's missing. There is no something plus the BI. And then your imaginary would be the, you don't have to write the I. That's what I was looking at. Okay, so it would just be 5. So the imaginary part's just the B, so the 5 would be the imaginary part that's looking for. All right, let's look at B. We have 14 plus square root of 7i. So your real is 14, and your imaginary would be square root of 7. Let's look at another one. Let's look at C. We have 6 minus 11i over 5. You have to rewrite this so it's two separate fractions. So this is the same thing as 6 fifths minus 11 fifths I. And now we can see that the real part is 6 fifths and the imaginary part is negative 11 fifths. Make sure the sign goes with the number. Let's look at one more. Just negative 13. So this case, my real part is negative 13 because that's the real. It doesn't have an I. But now my imaginary would be 0 because there is no BI. So every imaginary number can be written as a complex number, and every real number can be written as a complex number. Alrighty, let's see. All right, so let's work some more out. Let's look at number 3. Number 3 now says to solve each equation for x and y. So we have x minus 7 plus 4yi equals 3 minus 8i. So when you're presented with this section equals this section. So I have x minus 7 equals 3 for these to be equal to each other. Then this section equals this section. So 4y equals negative 8. So the sign should go with the number. But for these two to be equal to each other, that is what has to happen. So now I can solve them independently. So I'm going to add 7 to both sides. So I get x equals 10. That's what your x is. And then I'm going to divide by 4. So negative 8 divided by 4 is negative 2. And that's what your y is. And that's how you kind of solve these type of problems. And this is part A. Let's look at another one. Let's take 4y plus 7 minus 5i equals 11 plus xi. Okay. So for these to equal, even though it doesn't have parentheses, this 4y plus 7 must equal 11. And this negative 5 must equal this positive x. Now I can solve them. So now I'll subtract 7. 8, 9, 10, 11. What's that? 4. 4 divided by 4 is 1. So y is 1. And then x is negative 5. All right. Not too bad. All right, let's look at another one. Now it wants us to find the sum or difference. We're just going to either add or subtract. So this becomes 5 minus 3i plus 2 plus 7i. And we're just going to combine like terms. So I'm going to combine my real parts. So 5 plus 2 is 3. Now combine your imaginary parts. Negative 3 plus 7 gives me plus 4i. And that's it. Let's look at another one. Let's look at part B. Negative 7 minus square root of 2i minus negative 7 plus 3 square roots of 2i. So again, I combine like terms. This is negative 7 minus negative 7. So if you have to write that out, do it. Negative 7 minus negative 7. I'm going to write that out as my real part. And then plus, I'm just going to make it a plus, negative square root of 2 minus 3 square roots of 2. And then bring in the I. So what I could have done here is I could have wrote this as 5 plus 2. Where'd I get? Oh, I saw that minus there. That should be 7. All right, so that's 5 plus 2. And then this would have been plus, so negative 3 plus 7. And so that's how I got the 4. So that's how, and then with the I. So that's how you can write so you can see a little bit better. So these two negatives make a positive. So negative 7 plus 7 is 0. So I don't have a real part. And then negative square root of 2 minus 3 square root of 2 gives me negative 4 square root of 2 because there's an imaginary 1 there, and square root of 2 stays the same. And again, you can write it like this, or negative 4i square root of 2. Let's look at part C. So C is 4 minus square root of 5i plus square root of 2 plus 8i. Again, write it out as 4 plus square root of 2 plus negative square root of 5 plus 8i. Now, in this situation, I literally can't combine it any further, so you can just leave it just like that. I add parentheses, but technically you could just have the parentheses just here. I would write parentheses just for best practice, but you stop there. So kind of write it in and out, just like we've been doing to make sure we don't make any mistakes, and then we can see that we literally can't do anything extra. And that's pretty much it for 15.8. We only have one more section left, and that's just multiplying and dividing complex numbers. All right, that's all I have for now. I'll see you in the next video. Bye for now.